So let's give a warm welcome to Nathan White. Nathan White is the Director of Services at NodeSource. And for me and a lot of people in the company and people I met, he can be described as the most interesting man in the world. Once, and he's going to tell some mysteries, I don't want to spoil them, but once he took a bike from Colorado to Florida like 3 months, like by bike, like riding on 2-3 months, something like that. He can tell us a lot of different stories. And I tell you, every time I travel with him, something crazy and weird happens. So let's give him a warm welcome and a big round of applause to Nathan White.
I'll explain the kind of the little bit of the existential statement here at the beginning of this talk here. Julian did a great job of actually introducing me. I'm the director of professional services at NodeSource. I'm a fill-in for a gap that was in the schedule. So I'm stretching the limits as far as like covering JavaScript here. With my role, I'm involved with a lot of clients, and with that, some of the things I'm working on is helping people to make their code optimize and run faster. So that's kind of what the purpose of this talk is. I fell in love with JavaScript in the 90s, been using it, started off a lot of client-side stuff, like, even when XML HTTP requests hit like in 2001. Been involved in Node since 2009, worked at LearnBoost, helped out with like Mongoose.js. Some of you might have heard of that. There's my contact info if you guys want to reach out. So I'm going to go a little existential for a moment, kind of continuing on what Julian said. My own personal load test was riding a bicycle across the country. And so that's kind of where the topic came from. What I did was I cut up my credit cards, no cell phone, $300 cash, see how far I could get. I ran out of money in Kansas, so I ended up having to drive a tractor baling hay. In Michigan, I did lumber work. In North Carolina, I framed houses. There's a lot of stories. It's pretty dense. But in the midst of all of that, what it was is kind of my own endurance or load testing or stress test on myself. And as a result, there's a lot of things that I don't ever want to experience again. But also at the same time, I gained a lot of confidence in how I proceed forward, or knowing how I can adapt into any kind of situation. And we're going to kind of take that and look at that in terms of a code perspective with load testing. So why do we want to load test? There's a lot of different reasons, but most of it's going to come down to if we're building products or we're building applications for companies or where we work, it really comes down to making our management happy and finding the right tooling to do that, and also to make our customers happy. So why? It comes down to these really kind of simple things. Time is money. A faster experience equals a better experience. A better experience equals more improved conversions on your customers. So just some examples of this is Shopzilla, a 5-second latency reduction equated to like a 7 to 12% increased conversions on their site. Walmart has found that every 1 second of latency reduction increases conversions by 2%. Again, huge amounts of economics that can be attached to this, right? Mozilla, another one, they found that a 2.2-second reduction in the latency of downloads increased it by 15. It increased the download conversion by 15.4%. That's huge. So these are things to kind of think in mind when we're building applications and that experience, because when we're looking at it in a local mode might not be how it's being experienced across the world. So while while outages, this is some research that I found, 1 hour of downtime can actually equate to like 21K of revenue lost, kind of a typical average or median across the industries. That's mostly looking at like brick and mortars or like retail companies. But the interesting thing to note here is slowdown. So if your site is actually like performing a little sluggish, but it's still available, that can actually lead to revenue loss as well. And what we see there is, but there's a key thing here. We're looking at outages. The crazy thing here is slowdowns are 10 times more likely than downtimes. So there's twice as much revenue lost in your slowdowns of your site. So it's really kind of critical to be mindful of like those extremes, like the 90 percentiles and onward, to really understand how well your customers are being served. So that's kind of just one area or one perspective to kind of frame a mindset around load testing and why some of this stuff is kind of important. But there's more reasons. Some of those other reasons are you can find errors within your site, whether you're rendering pages correctly. You can check for 200s, or you can check to see if a gateway timeout or an API is actually overusing its limits, and how you might actually respond to those things. Stability. It will give you confidence in actually understanding where those baselines are at for your site and knowing your traffic patterns to avoid interruptions of your sleep at night, and getting that call that the site's down or something's not working or something's broken. And I think the most important thing, and to kind of loop this back, is a deeper understanding of the code that you're writing. And it will give you more confidence and more it will empower you. It will give you more tools and resources to kind of go in and fix those things and to have more ownership over the code that you write. And I think that's kind of the thing, the really important critical takeaway here, is to have that understanding. So going into how do we load test, right? So there's a lot of different tools out there. There's numerous different things. So we're gonna, most of you have probably heard of AB, which is Apache Benchmark, which is a simple tool to kind of run concurrency on your processes or on your website. There's also things like JMeter, which is exceptionally well, but it's actually really difficult to configure, but it can capture traffic and play it back. There's tools like Gore. The list goes on, and as far as what to use and how to use them. So don't use this as like a end-all, be-all. Explore, if you already have tools, look at enhancing them. Have conversations within your organization as to how you can improve them. One thing I will, in that list that I mentioned, AB is really not a good tool for doing load testing because it uses HTTP 1.0. It doesn't handle certain like keep alives. There's a lot of other kind of rudimentary things about it. So it doesn't really scale well for kind of doing more complex workloads. So when we talk about load tests, there's actually kind of a variety of different load tests, kind of patterns that you can tackle with your applications. So there's the virtual users that you just kind of ramp up over time. There's like the endurance test where you just kind of like saturate it or soak it over a huge amount of time. There's the stress testing where you kind of are continuing to ramp up users over a given peak of time. Or there's like the peak traffic, the spikiness, like where, online ticket sales are coming on within like 5 minutes, and so you might see an increase of traffic, and simulating some of those kind of patterns as well. So we'll talk about some of the scenarios and how you might be able to play those things out and to kind of be able to replicate those things within your environment. But they all have different purposes. And the load test is really to kind of get a measurement or a high watermark of how your app performs and where that scaling is at. And so that can be used within your CI/CD to be able to test to see if there's regressions within your application. Endurance tests, I think, are really important in terms of finding memory leaks. So you might, small little allocations or closures around memories within JavaScript, which sometimes is all too easy to do, is really difficult to see because of the way garbage collection works within like V8. So running a lot of traffic over a large period of time will actually kind of exaggerate that and actually help to narrow down and to find a memory leak within your application. Virtual users can actually help to see if there's any kind of like PI information, if you're having issues with state, or if you have different scenarios in your workloads of how that could actually bubble up and potentially what errors would be invoked from those kind of scenarios. So the tool that I'm going to be focusing in on is K6. And K6 is a load testing tool. It actually has cloud capabilities and to be able to kind of run it in a decentralized environment. So you can scale this up to like thousands of concurrent users. So it's actually highly efficient. It has a lot of interesting features. And it kind of ties into this whole theme about the mountains because K6 is a mountain, as you can see in this picture right here. So going forward with K6, why do I like K6 so much? Well, it has great support. You can run it in any environment. They have Windows binaries. They have OS X, Linux. They have Debian installs as well. There's Docker images, so if you want to run it in a container, there's that as well. So if you want to run it in a Kubernetes environment, that's there for you as well. All your tests are written in ES6, as we'll look at here in a second. It has the ability to do metrics and checks, which makes it really easy to kind of do baselines or to check to see the availability of like your API or a lot of other things. And it has a huge amount of power features like we don't see in some of these other tools like the A/B benchmarking. It has great SSL support, cookie support, WebSockets, so you can test out WebSocket applications. It has debugging of the HTTP applications itself. One of my favorite features, which really starts to get at like real life scenario testing, is HAR file support. So we'll look at that in a second. And it even has an API so that you can control the load tests, which we're going to look at with a little bit of code here in a second. So here's some basic examples of how you would run K6, right? So once you have it installed, K6 run, and you run your script, and that it fires it off. We can run a single VM 10 times, the iteration, 10 times, and it will run that. We can say we want 5 virtual users doing 10 iterations apiece. And so we can do iterations, or we can do it by a second, so we can do it by sustained amount of load. So we have a lot of different options. This option right here is a little bit interesting. So we can actually specify scaling. So what this is saying is we're ramping from 0 to 100 over 10 seconds. And so we can control kind of a ramp-up period and then a cool-down period. So we can kind of create these different load simulations very easily. And then I think for a data nerd like myself, one of the really kind of compelling features about K6 is you can actually output all the data into an InfluxDB to analyze later. So that can give you a lot of more insight and control and visibility to kind of analyze what your app is doing. So what does a simple script look like? So here comes the JavaScript part. So we can write stages in our application. We can control like whether we reuse a connection or not. We can configure other things in there like SSL and handshaking and whatnot. We can even define. But what we do is we export our default, which is a function that actually gets executed. So this is a really simple thing, and I'm allowing an environmental variable to be passed into the K6 test. And a user hits it, that backend, and it sleeps for 0.75 seconds, and then it makes another request, right, during that load test. And it's as simple as that. This is a little bit more complex example, but this gives you an example of like a real-world scenario. So we can import, we can define our endpoint. Here it's like 8080, and we're going to define workflows. So here's a login workflow. We have a token, and then we can actually post our login and you can see we do a JSON parse. And then we can check the results on our response. And K6 will actually output all that stuff. It will give us telemetry data and how many requests were being sent, how much data was going through, and what are those quartiles, like the median, and those ranges as far as our data that's being sent through the wire. So on to kind of the next feature that I think K6 has that's like incredible to use is you can go to your website, and your website will probably be making a lot of asynchronous requests for other data that's out there. What we can do is, like in Google Chrome, we can right-click on that network panel, and we can say save a har with the content. And what that will do is it will give us all the posts, objects, the cookies, everything. And then we can run with K6, we can convert that, and it will actually make a whole playback script with even all the time delays to allow us to have real-world playback on our applications, right? So getting to this, why is this so important? Why is playing back this data so important? Well, it gives us understanding and visibility of where our code is at, and it actually allows us another tool and another insight into actually writing performant code and to making it easier and accessible, right? So I'm going to kind of incorporate this with another tool. This is a tool that we built, which is called NSolid. It's a kind of just looking at it really quickly from a high level. It's a drop-in replacement for Node. You guys can download it off our website. It's free to use for like 5 processes. So it's a great place to start. What I'm doing here is I want to kind of show an integration. So the reason why we did it this way is to be able to pull out metrics and some other insights out of the runtime without modifying your code at all. So any of your applications that you have in Node right now will run with this, not a problem. And the reason why we built it that way is because of this important event loop that we have within Node. This is kind of a simplified version, but all the code, we talk about Node as being asynchronous. Well, the problem is all of the code that we write is actually synchronous, and we call back into this event loop. So, and there's these different timers. So the more we monitor Node, the more we actually slow it down, and the more that we actually impact the accuracy of those numbers. So the more we try to watch Node, the more it has kind of this toppling effect. So that's kind of why we built this sidecar in order to get those metrics. So it gives you the ability to kind of see things in pretty dashboards and whatnot. I kind of recommend you to kind of download and give it a shot. So that takes me out of this part. Let's get to the fun stuff, right? So what did I do here? So I went to a website. The first thing I did was I searched for one of the hot topics right now, right, in web development is Webpack, React, server-side rendering, and it can actually have a lot of performance implications on your applications. And so I wanted to kind of get some visibility or insight. So I did a search for finding just a random SSR example that's out there on the internet. And so this is what I found, and I got this up and running. We can go ahead and see this. This is an example of it running in NSolid. And so we can just see here's the process running and the amount of memory it has. Great. So what am I going to do here? I'm going to go ahead and fire this up. So I have this thing called Visual. I have all the code up in a repo, and this is all for you guys to go ahead and play with. So I'm going to go Node app. So it's listening on port 777. And what this guy does is it uses K6, it has WebSockets, and so now we can kind of see, it just uses an iframe to see the NSolid console within here. And we have WebSockets, and what I can do now is I can hit this route, and this will actually control the K6 API and start throwing load at it. So what we should start to see here is those numbers across the top are starting to change. Those are our real-time request response times. And then we're seeing the max times and the min times and the P90s and the P95s are going across the top. And what we're seeing across the bottom is a ramp up of that traffic. So we're throwing more and more traffic at this process just to kind of watch what it does and how it kind of interacts. And we can kind of start to see that it's starting to topple over a little bit as we're throwing more and more traffic at it. And the process is going over to the right, which is our CPU utilization. And we see the memory is on the vertical axis here. So we're up to like 900 requests, about 1,000 requests, and we can see our requests per second somewhere around 19. It's hanging in there. So this load test will be done in just a moment. It just finished up. So what did we do there? So we ran our load test, and now you can see all the CPUs is done, right? We could click on here, and we can actually see, we can kind of see the spikiness of that test, right? And we can see kind of the load that was in there, which is great. It kind of gives us a little bit of understanding, but it doesn't really tell us how did our app perform, right? So NSolid has an API, and that's what I kind of tied into it with K6 in order to be able to see these metrics. So coming out, I can now run node block. And what we're looking at here is in that time that we ran the code, we actually had two points in our code that actually blocked the event loop. One was we blocked the event loop for 465 milliseconds, and it gives us a stack trace of exactly where we blocked. It looks like this module React Helmet is not it's not the most efficient thing, right? And our second block was, we had another one that was at 319. I'm only logging ones that are over 400. So we had a total block time of almost a second of the event loop in that 1 minute test, right? So that kind of gives you ideas, and this will give you a good point of like maybe some code to go look at without having to go dive in or spend a lot of time investigating. It kind of is a pinpoint razor to where your problems are at. Now to kind of take that a step further of what we might be able to kind of, we ran this code, we don't really understand it, but so what did it do? How did the app actually perform? Well, good question. What we can do is we can run, let's see here, node parser, and I'm going to pipe this out to my graphs, public, baseline. So I'm just going to parse the raw data that I captured from that run, and I'm going to just save it into this graphs file. So what the graphs file is I just took the data from our run, and now we can go in here and we can actually visualize it. So what this is showing us now is this is a really simple thing. I'm open sourcing it now that you can run any of your applications on, and then you can generate these reports to kind of see, and this is great for your pointy hair manager to be able to show how your app is performing, or to kind of have visuals to communicate with your team members. And so this is showing our active requests, like the async handlers, what our CPU utilization is doing across the load of our test. Our test was only 60 seconds. We're looking at DNS, 99 percentile, median, the garbage collection CPU utilizations, some really kind of interesting things that we can kind of see our HTTP client request times and how spiky those are. So this gives you a lot of insight in terms of where some problems may be and how you might be able to drill into them. So that's kind of some of the generation, some of those reports. There's a more advanced feature that I'm not going to have time to go into, but it's in the code base. And you guys can kind of explore that a little bit more. And what it allows you to do is actually compare two runs together. And so you can take an A/B run, like a baseline, and compare it to another test, and kind of compare those metrics. And it's really going to design for like auto scaling. So like if you're scaling out a large number of processes to see if it's scaling efficiently. I'm sorry. And if you're using those resources, to their maximum potential while not degrading performance for your users. So that's kind of another topic, but this is actually generated to kind of design and aggregate that data in order to be able to compare across multiple processes and to kind of be able to look at those A/B comparisons across multiple runs. So that's kind of another kind of scenario, and that is in the code base too. So let's go to this. This repo is called 2018-JSConf.co, and it's private right now, so let's go ahead and go to settings. And I turn it on. Make public. Okay, so I gotta type that in. And there you go. And, oh, yay. Okay, now we're set. So it's public, and I think that's time. So I appreciate your guys' time, and thank you.